Hi guys, welcome back to my channel. So in this video we're gonna go over double integrals, and here we need to find the area of a given region, and this is the region that we have over here. So we're gonna be finding the area using double integrals. Okay, and for this, first of all, you need to know that this R means the region which is given over here, and if you're finding for any specific equation, let's say okay this one, if you're finding the dA, which means the area, and you need to integrate with respect to the given region, dx or dy, so you can take whichever one you want, the dx first or the dy first, but just make sure that these x values belongs to x values in here, and these y values belongs to y values in here. And this dx dy, you can always change the order, dy dx. It's gonna give you the same answer. Okay, so it's up to you, whatever you choose, but sometimes choosing one is easier than the other one, so you'll always have to draw it and then figure out which one is easier. In this problem, it's not the case. Whichever one you choose first, it's gonna give you the same answer, because these are constant values. If you have like an equation like we'll do in the next problem, so I'll show you, you'll have to draw and then figure out which one is easier. Okay, so let's start with this question first. Alright, so like I said, you can do dx or dy, whichever you want. So I'm gonna go ahead with dx first. Okay, so I am writing dx and then I'm writing dy. So first I write dx, so the x values that I have over here is 0 and 1, so the x values are going from 0 to x equals to 1. Okay, it's important that you write over here like x equals to 0, x equals to 1, but even if you don't write it, it's not a big deal, but it's just so you don't forget.
Yeah, it's not different.
Okay, so and then dy, because dy values belongs to -1 and 2, so that's why you're gonna write it like this. Okay, so then we need to solve it. So like I explained in my previous video, to solve such problems we always divide the question into two parts. So first part is this dx part that you see over here, and then the next part is the dy part. Okay, so first let's solve for the dx part, and whatever answer that we get from the dx part, we're gonna integrate it, that answer, with respect to dy. Okay, so we are taking this x plus y squared dx from x equals to 0 to x equals to 1, only this part. Okay, and since we're integrating with respect to dx, that means y is treated as a constant. Okay, so we're only differentiating the x, so which is going to be 2 over 2, and then since it's a constant, so we'll simply write an x in front of it. Okay, so this is like a simple integration problem, right? I hope you guys know how to do integration now at this point. X equals to 1 to x equals to 0. Okay, now we are simply gonna plug in the values from 1 to 0. Okay, so this is 1, and yeah, that's why I told you guys to write x equals to x equals 2, because it's really important to write x over here as well, so you guys don't mess it up with the dy, with the y values. Okay, so here we're gonna plug in the 1 over here, and then minus 0. This is gonna become 0, and this is gonna become 0 if you plug in 0 in here, so this is simply gonna be 0. Okay, so this is gonna be half plus y squared. Okay, this is the answer that we get from the dx part. Now we need to deal with the dy part, the second part that I told you guys. Okay, we're just done with the dx part, the first part. Now we're taking the outer part, the dy part. Okay, now we're going to take this answer and then differentiate it with respect to y now. Okay, And what are the y values that we have? So y values that we have is -1 and 2. So y values goes from -1 to 2. Okay, and yeah, don't forget to write the dy in here as well. Like once you're done with the dx part, you'll always need to write the dy afterwards, because some teachers are really picky about the notations. So you'll always need to write it at the end if you want. Okay, so here we can write the dy. Y equals -1 to y equals to 2. Okay, you'll always need to write it at each step. But you know, it's really hard to write it at each step. So that's why I always prefer to write it at the end once I have solved the question. Okay, now we can continue with our problem. So now this is a simple like integration problem that we did in Cal 2. Because there's no two variables involved, there's only one variable, y. So we are integrating with respect to y. So this is a constant, so y stays over there. And this is square, and we're going to add 1 to it and then divide it by the exponent. Okay, now from y equals to 2, y equals to -1. So we're gonna plug in 2 and then -1 inside it. So 2, first we're plugging in 2 inside. Okay, and then -1 minus this equation by plugging -1 inside this equation. Okay, and if you solve all this, so this should give you 1 plus 8/3 negative, this is a negative, okay, and okay, so this is gonna give you a plus 1/2. Oh wait, was that negative for half? Okay, no, never mind, that was positive. Okay, so when you're going to multiply this negative with the negative, so then it's gonna become positive. And then you have this -1 to the power of cube, so that's gonna become -1/3. And when you're gonna multiply this negative by this negative, so that's gonna become positive 1/3. So then the answer is, alright, so if you add all these up, so this should give you 9/2. So this is the final answer to this equation. Okay, if you have any questions, any doubt, let me know in the comments below, and let's move on to the second question now. Alright guys, so this is our second problem over here. So in here we have a region. Here we need to find the area under the region, and the region is given by the constants over here. But here we have an equation over here. So like I said before, if you have an equation, so you'll need to check whether you're gonna integrate with respect to dy first or dx first. So this is what we're gonna do, and for that you'll always need to draw the region. Okay, so let's go ahead and draw this region. So here we have y equals to 0 to y equals to 1 minus x square root of x. So this is simple. This is simply a square root function where you can simply find the 2 points in this equation by plugging x equals to 0 and y equals to 0. So you will get 2 points, 0, 1 and 1, 0. So we're going to plot these points. So we have, let's just say this is 0.5 and this is 1. So we have 1, 0, and we have 0.5, and then this is 1, and we have 0, 1. Okay, so this is the next point. So this is the first point, and this is the second point. Why it's removing by itself? Okay. So next, you guys see there's a negative in front of it. The x, if it was like a positive, like 1 plus x, so then we would go, the square root would be in this direction. But since here it's a negative in front of the x, so the square root function will go in the other direction like that. Okay, so this is how your square root function is gonna look like. Okay, so and then y equals to 0. So here we have the next function, which is y equals to 0, which is nothing but simply an horizontal line over the x. Okay, so this is y equals to 0. Okay, next we are now done with the y values. Now we need to look at the x region. Okay, we have just plotted the y region. Now let's look at the x region. For x we have first x equals to 0, and then we have another equation which is x equals to 1 over 2. Okay, so first let's plot x equals to 0. So this is x equals to 0, right? So what I just plotted in blue. So this is x equals to 0, and then we have x equals to 1 over 2, which is 0.5. So this is gonna be a vertical line over 0.5. Okay, so this is what my region is gonna look like. Okay, so here, so we got here two regions, but which one belongs to our problem? Okay, so for that you'll need to figure out that which one belongs to both values, the x values and y values. So here we have the x values going from 0 to 0.5, which is good, and here we have y values going from 0 to negative 1.1 minus x square root. So this is from 0 to square root. So this area is good. However, this area is not good because the x values are going from 0.5 and 1, not 0 and half. So this area is not good. This is our region. This is the region that we are looking for to find the area. Okay, so I'm just gonna color this region. Okay, so we're talking about this region. All right, so once we have drawn our region, now we can come back to our problem and figure out which one we should derive with respect to first. So we're going to rewrite the problem here, 2xy integrated with respect to dx or dy first, right? So here, if we're choosing to go with respect to dx first, okay, so that means we're always going in this direction. Okay, so if we're going in the dx first, that means we are differentiating in here. But if you guys notice it carefully, here you guys see these two arrows are between the same two lines, okay, here in this region. But as you move forward, like upwards, these arrows do not belong to these two lines. They tend to touch these two lines, not these two blue lines. So they tend to touch the other line, the blue and white line. They're not between the x values that we chose. And these two x values, they are crossing the y graph, not the x graph. So every time you face this situation, it indicates that you cannot use the dx first. This is gonna be wrong, or it's gonna be like it's gonna take you forever to solve it. Okay, so never go in the dx first every time you face this situation. Okay, so that means, which indicates that we should go in the dy first. Okay, but just for the sake of practice, let's do this line thing with the dy as well. Okay, so we're going in the dy direction. So that means we're always between these two y lines. Okay, so are we always between these two y lines as we move forward? Yeah, that's true. No matter how far we go, we're always between these two lines. Okay, the y values that we have, the y region. So that means it's correct. We are going to choose to go in the dy direction first. Okay, so dy, and then we have dx. Okay, so now our job is easier now. Dy, so what are the y values belonging to the dy region? So we have y equals to 0, and then we have y equals to 1 minus x, and then what are the x values? X values is simply x equals to 0 to x equals to half. Okay, now we're gonna solve it. It's pretty easy to solve it. Okay, I'm just gonna zoom out it a little bit. Okay, so like I said before, we're dividing the question into two parts. First the dy part and then the dx part. So dividing the first part, so we have 2xy dy, y equals to 0 to y equals to 1 minus x. Okay, so we're integrating with respect to dy, which means the x is constant over here. So we're gonna treat it as a constant and put it aside, just like the 2, and then integrate the y. So that's gonna be y to the 2 over 2, and 2 cancels out, and then we can solve for y equals to 1 minus x to y equals to 0. Okay, and then we're gonna plug in these values to within the y values. So we have 1 minus x squared. It's a square, but here we already have a square root over here. So the square root and square, it's gonna cancel out each other. And then we're gonna put minus, and here the y value is 0, so this whole equation is gonna be 0. So we're left with x times 1 minus x, and this is 0, so you just ignore it, and then you're gonna multiply it, so that's x minus x squared. So this is the answer to the dy part. Okay, now let's do the dx part. Okay, so we're doing the dx now, and for that we'll need to write the dx over here again at each step. Okay, now we can finally integrate it with respect to dx. Now we have only one variable left. We no longer have two variables, so that means it's a simple problem like we did in Cal 2. So here we can integrate it with respect to x. So this is x, that's gonna be 2 over 2, and minus this is squared, so we're gonna add 1 to it, and then divided by the 3, and then we're gonna solve it from x equals to 1 over 2 to x equals to 0. Now plugging in these values, x equals to half and 0. So we have half divided by 2 over 2 minus half cube over 3, and then minus, this is gonna be 0 if you plug in 0 inside it, and this is gonna be 0, so this whole equation is gonna be 0. And then when you solve for this, this should give you this 0.125 minus 1 over 24, which gives the final answer as 1 over 12. So this is the final answer to this question. Thanks for watching, and don't forget to check out the notes in the description below. Bye.